Hello guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss this very interesting problem of GFG PotD in town. So let's move on to the problem. So this is a problem given to us in which we are given n houses numbered from 1 to n and they are connected via n minus 1 bidirectional road. Okay, so we can say we have n vertices or nodes and they all are connected with each other with n minus 1 edges. Okay, so here we have to find out the minimum distance uh, because they want to do a party, so we have to find out minimum distance of all houses from a particular house. Like for this given case where we have four nodes, first, second, third and fourth, and three road, first, second and third, and we have to find out the minimum distance. Okay, minimum distance from a particular node. Like suppose if we are doing a party at 1 at this house. Okay, then distance of 1 comma 2 is 1, 1 comma 3 is 2, because we have to two nodes, first, second. Okay, similarly for 4 it is 2. So for 1 the maximum distance we need is 2. Now for 2, the maximum distance for 1, 2 and 3 is 1. So maximum distance is 1 for all the cases. Now for 3 it is 1, for 2, node 2 it is 1, for node 4 and 1 it is 2. It is 2. So maximum distance here as well is equal to 2. For 4, here for 3 and 1 it is 2, for 2 it is 1. So maximum distance is equal to 2. So at last you can say the minimum distance we can get the minimum distance that we can get is from node 2, that is 1. So we have to hold the party, do a party at house 2, so that each one can reach at house of 2 in maximum one distance. Okay, so here 1 is our answer, the maximum distance. Here you can see. Or suppose like if we have some other thing like one more case, like this is our tree connected like this, or I should say like this, one connected to 2. Okay, this is a node, then 2 connected 3, then 3 connected 4, then 4 connected 5. Suppose now for 1 the maximum distance is of 5, that is 1 2 3 4. So you can see the maximum distance we need for node 1 is 4. That is because if when 5 come to a party at home 1, then it need to move 4 distance. Okay, so maximum distance is 4. Similarly, in case we hold a party at node 2, the maximum distance we require is 3, that is 4 node 5. Now if we hold a party as at node 3, then the maximum distance we need is 2, because node 1 and node 5 both of them will take two nodes, will take distance 2 to reach at the home of 3. Now for 4 it is 3. Now why 3? 1 2 3, 4 node 1. For 5 it is 5. Why 5? Sorry, it is 4. 1 2 3, yeah, it is 4. It is 4. It is 4 for node 1. And if we have a only even number of nodes, okay, so we will take optimal node is 3, because the maximum distance here is 2. But now suppose if we have a node only 4 node, suppose, so in this case we have an answer as 3. Suppose if we have a node, then maximum distance for 1 is 3 for node 4. Okay, this is our node. Maximum distance of this is 1 1 2 2, that is for node 4. Maximum distance is 1 2, that is for node 1. The maximum distance is here is 3 for node 1. Now what we can do, we can do a party at home of 3 as well as we can have a party at home 2. So we can return 2 as well as we can also return 3. Okay, there is no compilation in our array, there is no optimization we need to return any PotD. Okay, we have to just return the optimal PotD house, okay, in which we can do the PotD. So what we will do, how we will do, from each node, as you can see, the time complexity is n square. So from each particular node, we will do DFS and try to reach out every home one by one, as many homes possible, and find out the maximum distance, or find out the farthest node. Okay, the most distance node from this particular node. So the distance between this and this is our answer, because these all are at minimum distance than this and this. Okay, so our answer is for node 4, that is 3, for node 4, that is 2, for node 1, because here we come at here in just one move, but we can reach 2 as 1 at 2 move. Okay, so answer is 2, but for node 1, here 2 for node 4, for 3 our answer is 2, but for node 1 here answer is 3 for node 1. Okay, so uh, we will do DFS. So DFS will take n time, one time, because we have to try out to reach the all possible nodes, and okay, and for all we are trying to do, that's why into n. For one, it is for one node. This is time reach. For a starting node n, so total time complexity is n square. Okay, for total time complexity is equal to n square. So I hope you will understand this. Now what we are doing, we are taken answer is equal to into max. Now for I is equal to 1 to I less than is equal to 1, we are taken current is equal to 0, means our current maximum distance is equal to 0. So we are passing this list ith array, the parent array for doing DFS, the parent node. The parent node of 1 is -1, because 1 is the root node we are taken. Okay, now 0 is the current distance. The distance from ith node to ith node is always 0, and this is current, that is our answer. We will modify it. Then after each stage, we are update our answer as answer is equal to minimum answer comma current. At last we just return answer. So how we will do DFS? Now we will look into the meta. Like here, a vector ith node means current node, p is parent node, means p means parent node of ith node. Now this is current, our answer, this is distance. So our current, and each iteration we will update our current as well. Okay, current here, you can see I pass over at reference, so it will update accordingly here as well. Okay, so here we are maximum. Now for each node, like suppose we have this, and for this our parent is 1, so our I, uh, for here our I is equal to 1, parent is equal to -1, parent is equal to -1. Now we are go to 2. Yes, we can go freely. We can go now. Here our I is equal to 2, parent is equal to 1, parent is equal to 1. Now when we are iterating all neighboring nodes of 1, then 1 is 3, 1 is 4, we can iterate them. Okay, but now when there is also one node, that is 1, but now you can see 1 is also a parent node. So if we go on 1, then from 1 we come on 2 again, then this will make a cycle, and we go running time error. Okay, running time error we got, because it is a time complexity and time limit exceeded case. So what we do, if our neighboring node is the parent node, our neighboring node is a parent node, then we will just continue, we will not come on this node. We can see, if my k node is not is equal to my parent node, then I will do DFS, unless if they both are equal, then I just continue, or you can see I am not doing any operation. So now I am doing operation, like how operation A. Now current node is my k, parent node will become my I. Now for 3, my current node will become 3, my and my parent node will become 2. My parent node will become 2, means the ith node of here became the parent node of this. Okay, the ith node of there became the parent node of this. So you can see, ith node here I am passing it as parent, the current node is k. Now current and incrementing our distance at distance plus 1. So I'm just compile and run it. So you can see correct output is, it is given. So you can see all the 12 test cases pass out. So I hope you all understand this. This is a very simple approach of DFS. I hope you all understand the approach. If you still have any doubt, then just comment out. I will try my best to explain you. Meanwhile, you can subscribe the channel, like the video, and if you like the content, then please comment out, and it will motivate me to make more content like this. So thank you for watching this, guys. Stay tuned.